end of space-time, or space-time is doomed. You might have heard dramatic sounding statements like this among personalities who have a say in physics. And it is a strange augury, but it makes a lot of sense. Since Descartes and Newton established space and time as a fixed framework where you can locate things or matter using few coordinates, both notions have been forced to twist and warp in order to adapt to the new forthcoming concepts. You know, relativistic geometries, quantum weirdness, singularities. From relativity, we know that space and time are different for different observers, and somehow they transmute one into the other when you change your frame of reference or in the proximity of our masses. Also, from quantum theory, we know that no longer we can locate things, at least particles, in space and time precisely, because we have the uncertainty principle. The new attempts bring up more weird stuff, like roll-up space dimensions or space-time divided in tiny chunks. More and more scientists today expose strong convictions that the space and time are not fundamental and should not, therefore, be part of a basic description of reality. Even when so many claim it, I have the feeling that very few theoretical physicists really try to get rid of space and time in their works. And that's normal, because it means somehow erasing the ground where you have always had your feet on, and that can leave you swimming in dizziness. But avoiding space and time in our description of the world could be more natural than it seems. In fact, for ancient philosophers, the concepts of space and time were much more diffuse and less absolute, kind of what we are being forced to get back now. In this video, I'd like to put forward what I think could be the most immediate way to start building a more fundamental description than space-time. And for that, I will be using a little example. We will need a lot of small balls and a very large box. We should place the balls inside the box, giving them initial conditions of position and speed. Then we simply let everything run its course. We can have gravity or not inside the box. Indeed, we can have any force field as exotic as we want, but requiring one thing, that the interactions between balls, which are the collisions when two balls find each other, must happen only in pairs. In principle, we don't care the details, but we have to keep the concept of an isolated collision of two balls. We will make all the balls with the same properties, and we will also make the box 2D to visualize this better.
Suppose we zoom in on a small area of the box. There we see balls colliding, let's say like this. An observer outside the box can describe what is going on here using the positions of the balls and a clock, labeling collisions with space and time in this way.
A simplification of this method could be to ignore the positions and write down for each collision the time of the impact and which two balls collided. You could also disregard the exact time and keep only the order of the collisions, regardless of the interval between them.
After doing this, intuition tells us that we must have lost quite a bit of information. But let's continue. It can be raised that the description of an external observer is not very coherent if we want to imagine that this box is a model of a universe. The description should then be made by the balls themselves. If the balls neither have a watch nor a way of knowing where they are, we could say that their description could be the list of the other balls with which they collide, and, in any case, some internal effect of how strong the collision has been, something like how much it hurt. For example, if we follow the number 8 ball, we get the sequence of its collisions. On the other hand, and giving a nod to relativity, one can discuss the impossibility of determining the order of two events in which same actors do not participate. For example, we cannot intrinsically decide if the collision of the red ball with the yellow one was before or after that one of the blue ball with the purple one, if we cannot link the two events through a chain of other events. But if we follow the rest of the balls as we did for ball number 8, we'll find those links, and all collisions together will shape a network. If we think of the story that one of the balls in the previous case would tell us, we can imagine a particular event as a starting point from which we begin to count events. However, the choice of ball or event is completely arbitrary.
If we assume that the balls are perfectly elastic, then collisions are time-symmetric. So, we can run backwards the unfolding of the events without any possible way of knowing that we are going towards the past instead of the future.
So, any ball can start a clock at any time and also choose the direction of the arrow of time. If we go a step further and consider that the balls are all identical and indistinguishable so that they can be effectively interchanged at each collision point, then we can realize that we have eliminated all traces of time and that our network can be traversed in any way we want and topologically remains the same. This is, any story can be read on the network by traveling it in any possible way.
This will be a natural feature of the networks I will discuss later. As long as no additional information is given, there will be no definite way to read what is happening. I know this is nothing new. In quantum field theories, for example, you have more or less the same effect. In any Feynman diagram, you can switch time and space axes and also invert the orientation, not affecting the physical event, but only the way you visualize it. Lorentz invariance is what ensures that you will have the same process. Anyhow, when you perform the calculations, space and time are still there. Not only this one, many other theories, which are brand new attempts, are also completely founded in a definite dimensional spacetime. And as in here, note to myself, I should make another video explaining which theories I think go beyond spacetime and which of them don't. So, the deep question here would be, would there be enough information in the network only to reconstruct the box and to generate a spacetime inside it? And also, a new way to make physics in this box could be the following. From the list of the interactions that could be infinite, of each all against the others, and also some internal information that we grant to the collisions, could there be a rule that having nothing to do with space or time can also tell us which the next
events are? At first glance, it seems very difficult to believe that from the network only you can get spacetime, not to say a predictive rule. But what if the number of balls is enormous? And what if the elapsed time is also enormous, so that the information you can get from the collision is huge? I'm aware of how ambiguous this is right now, but there are more things to add in the next chapters.